Bismillahirrahmanirrahim. Ladies and gentlemen, I'm Dr. Malik, and today's topic is very important. It is about sugars and how they damage our cellular health. Do not miss and try to get notes. And the pattern of today's video is quite different than usual. I'm not sitting at a desk. I'm moving around, enjoying a good weather here in Chicago, having a walk and the sunshine. It's the morning, just the rise of the sun. An early morning walk is definitely very pleasant. Some cool breeze. I can feel a very pleasant cold. It's not so severe, or it is not giving me any unpleasant feeling. So coming to the point, table sugar is what is our everyday consumption. Rather, I will say now it has got the value of a staple food, a staple diet, and actually it is not a food at all. Even it is not something to be included in our diet on a regular basis. Table sugar is composed of two substances, two molecules. One is glucose and one is fructose. We can get glucose from other sources like starch which is found in most of the grains, in some vegetables like root vegetables, potatoes, sweet potatoes, and fruits do have some fructose, and most of the fruits, they are loaded with fructose. We got table sugar from some plants. We got it from beetroots, we got it from sugarcane. We extract it, and with this extraction we purify it and we make it very strong. So the availability of both of the molecules, glucose and fructose, is very immediate, and this sugar is immediately absorbed into our blood, and it gives a big spike in our blood glucose levels, and that is what we are exposed to with this table sugar, and that is what is dangerous. Now, how it is dangerous? When we say glucose is needed by every cell of the body, yes, that is true. All the cells in our body, they need glucose, they use glucose. And what they do with the glucose, there are small particles in the cells called mitochondria. Those mitochondria, they are having chemical reactions to produce energy, and the energy means they are producing adenosine triphosphate, ATP. They convert adenosine monophosphate into adenosine diphosphate and then into adenosine triphosphate. Normally, in every cell, if they are consuming glucose as the source of energy, they transform that glucose and convert it into carbon dioxide and water, And in the process, which is called a Krebs cycle, a chemical cycle having different stages and phases, which is regulated by different enzymes, this glucose is converted into carbon dioxide and water, but in the meanwhile, about 36 molecules of ATP are also released. And these are used for different functions of our cells. Now the question is, why the cells are producing energy? Why they need it? Because for the continuation of life, for the continuation of existence of those cells, cells of every part of our body, muscles, neurons, kidney, liver, epithelial cells, glandular tissues, glandular cells, everything needs energy for their existence. And at the same time, this energy is required for the functions of the organs which are made with those cells. Now here comes the actual point. Well, I'm saying that my muscle cells are making energy. They need energy for movement. If I am moving, that's good. The energy is consumed. My muscle cells, they are designed to make energy for my movement. Their mitochondria, they are designed to make energy to assist me in the process of motion. Similarly, my skeletal system, my bones, they are designed to help my limbs, my trunk, and the muscles to support them, to move, to do different jobs. When I'm not moving, it means I'm not utilizing the energy. I'm not using that energy, or I'm not using the exact usage of those mitochondria or those cells in my skeletal system, in my bones, in my muscles. I can elaborate this with another example. I will say that I have a car. I take that car, I drive it, I drive almost 300 miles a day, and the fuel tank is empty. I go and refill the tank. That's fair. I used that energy for the purpose I got it. But if I drive only 5 miles a day and I assume that my fuel tank is empty, which is not, and I go on a gas station and try to push gas into my fuel tank, where it will go? It will overflow. It will not be retained by the fuel tank because the fuel tank has a limited capacity. That's what we are as a human being. Our body, our fuel tank is a complex than a car's fuel tank. We put energy in stomach, food, in gastrointestinal system. We digest it, we absorb it. From blood, goes into the liver, processed into small tiny particles like amino acids, like fatty acids, like glucose and fructose, and then utilized by the relevant cells. So our fuel tank is scattered into stomach, intestines, liver, and associated systems. And this is the source of energy. But the usage of energy is to move. If we are not moving, and guys, you can see that God has made us in a way that we have a lot of muscles. We have muscles everywhere in shape of cardiac muscles, smooth muscles, and the skeletal muscles. We have a lot of bones. The maximum mass of our body is made up of muscles and bones, and they are supposed to be the biggest source of consumption of energy. If we are not using these parts of our body in a proper way, it means we are not using that energy in a proper shape, in a proper way, and still we are eating. That means we are trying to refill a tank which is already full. Now here comes the problem, because in a car refill, in a car's tank, there is an overflow pipe which takes, if we are putting the gas in, it will take away. But in human body, we don't have that sort of mechanism. So this becomes a stress on our mitochondria. They become dysfunctional. It is not bad that they do not want to perform their work. They want to do it, but we are not using what they are producing. So they become overloaded and they become dysfunctional or less functional. Now, at the same time, the sugars we are eating, they are producing other hormones like insulin. Now, insulin is not only doing the job of moving glucose from the blood into the cells, but it is also asking the cells of different parts of our body to proliferate. Insulin proliferates the cells anywhere in the body, particularly in the vessels, in the kidneys, in the brain, and it asks the mitochondria to make more fats for the storage of food or the nutrients to be used in some odd and awkward situations in the oncoming days. And when this command of insulin is prompted to the liver cells, the hepatocytes, they start making triglycerides and other fatty acids, which are taken away by blood into the bloodstream and then into different parts of the body, taken into the muscles. And lipocytes are the fat cells. They are stored there in subcutaneous fats, in central fat, even in muscles. And this is a disease. Ultimately, we are getting weight, we are getting obese. So the conclusion of the story is, sugars, when they are taken, they stress out the process of oxidative phosphorylation in the mitochondria. They produce oxidative stress and they produce fat, unnecessary, unusual, which is not needed. And ultimately, we lead to different sort of issues and problems due to that fat, due to that accumulation of fat. We suffer from different diseases. I hope you enjoyed this discussion, and I hope you enjoyed the weather. If so, please like the video, share and subscribe. Thank you very much.